we have a statement like null hypothesis. Null hypothesis is a starting point. We will test whether the value stated in the null hypothesis is true or not. Okay, so here, like there's an example here that everyone is accepted as innocent. Okay, at the beginning. Okay, so H0 is that there is no difference. Okay, so this is just a joke here. So everyone is accepted as innocent, and we had to prove that he has done a crime or robbery. What is that? Okay, so we have to prove that. So here H0 is indifference. Okay, there is no difference. And alternative hypothesis is just that we are testing the null hypothesis is wrong because we want to have an alternative hypothesis. For example, that believe the children watch more than or less than 3 hours per week. When we are uncertain of the direction, we can state that the value of null hypothesis is not equal to 3. So let's discuss how we can create hypothesis here. H0. Children watch TV not more than 3 hours per week, for example. Okay, or this is H0. Or H1 is children work more than 3 hours a week. If we state more than 3 hours a week, that's hypothesis 1. We can have even as hypothesis 2, we can increase it. Children watch TV more than 6 hours a week. Okay, so we can have alternative hypotheses, but alternative hypotheses other than 0 are not indifference hypotheses. They have a difference. They are bigger, they are smaller, okay, or there is a difference. Okay, so only H0 null hypothesis is indifference hypothesis. This is a universal definition in biostatistics. It doesn't change according to country, whatever it is. Everyone is describing this using these names. So this is universal language in papers that you can see. That H0 is always, there is no difference. Okay, so in most hypotheses we have these signs, bigger than or equal to, smaller than equal to, but for null hypothesis we say that, okay, no difference. Okay. Yes, okay, here p-value and significancy. Let me talk a little bit about this. What is p-value? And p-value is a value that we obtain as a result of this test, okay, which we are going to see in detail next semester. But for this semester, we learn the names. We know that for parametric, we have an independent t-test. It has a p-value as a result, okay? ANOVA has a p-value. All of these tests has a p-value. Okay? You deliver this test to reach a p-value. And according to this p-value, you reach the conclusions. Okay? And you can hear that confidence intervals, like 95 confidence interval, 99 confidence interval. Let me talk about that. Here, 95 confidence interval. And we have a statement like 99 confidence interval. So what is the difference between these two? 95 confidence interval means that our results are true 95%, but can be false 5%. Okay? This means that, so results are true, can be false. Okay, good. Now here, what this means? This means that results are true for 99% and can be false for 1%. And in health, in biostatistics, we want to reach to this result because we are dealing with health, and the more that we are close to the 99% reality, it is better. Know that there is no such case in science like 100%. Okay? You can never be sure that if you go to enter an operation, even though it's a simple operation, if everything is okay, if you are amazed that maybe everything is good, if not, the patient is in good condition, you always have 1% that there will be a problem. Okay? There will be that thing that an allergic reaction, whatever it is. So always there is 1% risk in every simple, every clear, whatever you say. And we, in science, we don't accept that 100%. But 100% everything will be okay. There is not exception. Always there can be an obstacle, a problem that cannot be prepared. It cannot be think before. So in biostatistics, the highest percentage we can have is 99%, and that's good enough for us. As a result of this test, we expect this. Okay, so here, as a result, we have a p-value, as we say, and if this p-value is now 0.05, is this 0.05? 5%, yes, okay. So if p-value is smaller than 0.05, we say that there is significant difference. And this is H1 hypothesis, okay? So accept, this means that accept H1 hypothesis and reject H0. Why reject H0? H0 is independence. Okay, there is no difference. So this is p-value here, and here this p-value, here this is 0.01, okay? In this case, as a result of this test, we find a p-value which is, if it is smaller than 0.01, then we say there is a difference, and we accept H1 hypothesis and reject H0. Now, with these definitions, you have this here. If the, yes, this is a graphical, you don't need to learn the graphical thing. Yes, here, I'm coming here. Yes, this is another thing that I want you to learn, that we can have mistakes. In studies, there can be some mistakes, and we have to know about that, but it's not our mistakes. Maybe that they are misinterpreted, some results may be misinterpreted by scientists, and maybe that they don't understand how they can have mistakes. Let me show you sample which can be mistakes, for example. Yes, here. For example, here, let us say these numbers, okay, not this one, for this one. Let me talk for this one. Okay, 95% confidence interval. Okay, so for this one, I have to work with 0.05. Okay, So if this number is smaller than 0.05, we say that, let us say that these are p-values. If they are smaller than 0.05, we say that there is significant difference. These are p-values here. Okay, these are p-values. So you will have such questions in your exam. Okay, and I am going to give you p-values, and I am going to say, okay, is there a significant difference according to this p-value? How you can understand that? Considering, I'm going to say you only consider 95 confidence interval. If I say 95 confidence interval, you check with 0.05. If I say 99 confidence interval, you have to check with 0.01. You compare with 0.01. Now here, I say 95 confidence interval, so I look here. Is this one smaller than 0.05? No, it's just the same, so I can accept that there is difference or not. Okay, here, is this smaller than 0.05? Is it smaller or bigger? Who's going to tell me? Smaller? Bigger? Small. Okay. Smaller than 0.05. Okay. Therefore, we say that there is a significant difference between the measurements. Okay. So this one. So and this is H1 accepted. Accepted because there is difference, and H0 rejected. Okay, so here, small or big? Small. Okay, so if a statistician makes a mistake and says that this is big, okay, if they say it is big, then they make a mistake. In this case, okay, so if the reality is that retain the null, what it means, if the reality is that there is no difference, this is the reality, and yes, it says okay, then this is okay. But if the reality is that they say there is no difference, the reality is this, and here they say it false. Okay. If there is no difference and the statistician says there is difference, this is type 2. If no difference and there is difference, this is type 2 error. If they reject the null hypothesis, okay, if they reject the null hypothesis, what this means? Null hypothesis is indifference hypothesis. So if they reject null hypothesis, they say that there is a difference. And if there is a difference, they say that there is a difference. And this is the reality. Okay, this is the reality. Let us say there is a difference. But they misunderstand it and they say there is no difference. Even though there is a difference and they say there is no difference, this is false and I want error. Now, when there is a difference and they say there is no difference, I want error. When there is no difference and the statistician says there is difference, this is type 2. So these are some errors that you can see on papers. Yes. Okay. Yes, you can see this situation here. If H0 is true, we reject it, it's type 1 error. If H0 is false and we don't reject it, this is type 2 error. And we have some examples here. Actual situation, for example, let us, the court case is interesting. That's why that I have some court case examples here. If the person is innocent, okay, and we say, no, he has guilty. Okay, person is guilty. This is our type 1 error. if the person is guilty and we say that not guilty, this is type 2 error. Okay. Yes. Okay, here, so you have to know the correlations. This is a positive correlation, okay, here. This is strong, this is weaker, this is negative correlation, and there is no correlation. Yes, okay, so here, these are the cases where we have no correlation. Let me show you the numbers. Yes. Okay. So I'm going to translate it to English here. So this, if you have these measurements, this means that there is a weak, very weak correlation. This is low correlation, and this is medium correlation. Okay. And this is strong, and this is very strong correlation. And for the last thing, please know the measurements here.